Good afternoon, everyone. Thank you so much. My name is Imani Ahleri. I'm a director of the strategy accounts for Mitacs. Special thanks to CUTRIC for providing this opportunity for all of us to come together for this quite interesting day of conversation about smart rail technologies. And at Mitacs, we are really proud to be sponsoring this particular panel, which will be looking into Hydrail in the Canadian context. A little bit about my tax. I'll keep my remarks very brief and invite you to connect after the fact. I'll be more than happy to discuss one-on-one. But broadly speaking, trying to move on to the next slide here. We are a not-for-profit organization with a mandate of driving innovation and productivity in Canada, particularly by fostering industrial and academic collaborations, with a specific look into providing opportunities to students to work on site with companies, helping essentially the industry partners with a variety of innovation challenges by making use of academic collaborations. 21 years in operations, a major player in the ecosystem, with presence nationwide, from coast to coast to coast. And together with our 6,000 plus industry partners who have been active users of our programs, including not-for-profits such as CUTRIC and all the secondary institutions in Canada, we have proudly sponsored over 35,000 innovation projects. The portfolio this year, for example, includes around 17,000 internship placements for a student, and that reflects a $250 million plus investment in innovation. We deliver this programming and this mandate using a few vehicles, a few programs. I wanted to particularly highlight a couple of them today, but before that, I wanted to also overview how broadly Mitacs will be able to work with you and help you. Our model of engagement and collaboration is a very evolved model built on essentially connecting with our industry partners one-on-one, helping to create an innovation roadmap by looking into your current state, your ongoing business challenges, or the future challenges that you envision to try to address. We will work with you on essentially determining a desired outcome set from an engagement with a post-secondary institution. Mitacs is then set up to tap into our national network of business development officers who are placed in each and every academic institution across Canada to essentially help find and pinpoint the right academic expertise and the right academic group to help you address your innovation challenges. And that includes assistance with recruitment of highly skilled talent. And these are students from a variety of levels that are quite fit for addressing the projects. And last but certainly not least, at the end of this engagement comes funding. And Mitacs, as a funding partner, is set up to essentially cost share these projects with industry partners. Our model essentially follows a dollar leveraging sort of format that would see us matching industry contributions to these projects. So all in all, as you can see, we are de-risking the entire process of engaging with academic institutions in Canada, both from an administrative and logistical perspective and also from a financial perspective. And as I mentioned, I wanted to highlight a couple of offerings today. One being our predominant program, basically our oldest standing model called Mitacs Accelerate, might be familiar to a number of participants. And the model essentially involves a multidisciplinary sort of platform or program that is set up to support a small or large scale collaboration ranging from $15,000 in funding all the way to multi-million dollar collaborations with a high success rate of over 95%. It's a non-competitive model with a relatively quick turnaround time of 6 to 8 weeks. And as I mentioned, we are with you and involved essentially throughout the whole matchmaking process all the way to funding. On the other side of the spectrum, I also wanted to introduce a rather newer member of the family of our programs introduced this year essentially as a pilot. It's called Business Strategy Internship Programming. To the contrary of our Mitacs Accelerate program, which is set up to support more traditional sort of R&D engagements between industry partners and academic institutions, business strategy internships are designed to look into some non-traditional aspects of collaborations and supporting talent basically in addressing a variety of business strategy needs or operations projects. I thought basically given the context of this particular context, looking at a variety of novel technologies, there might be elements of this program that might be useful. For example, as they connect businesses to a variety of law schools, you could look into soliciting expertise from these schools to look into a variety of, for example, IP law questions revolving around, say, hydrogen incorporation into the transportation systems. Same cost sharing model, different cost levels, which I'll be more than happy to discuss one. Last but not least, I want to share with you my contact information. Also, special thanks to our federal and provincial funders across Canada. Without the funding, these programs would not be possible. I'll be more than happy to engage one-on-one with all the conference delegates, basically learn a little bit more about your ongoing business challenges and help you pick the right elements of Mitacs programming that come to serve your innovation challenges. And with that, I would like to pass on the virtual microphone to Robert, the moderator of this panel. Thanks again for providing this opportunity. Robert, back to you.
Thank you, Iman. And I just wanted to mention that my company has leveraged Mitacs programs, and I now have the University of Waterloo and 3 students under the internship program. So I can support the helpfulness of your programs. Welcome to the session on Hydrail, the electrification of rail in Canada. And today we have an excellent panel of speakers. I will introduce them each in turn, but before I do that, I'd like to just give you a quick summary of what it is we hope to cover today. So for more than half a decade, Ontario has been exploring the implementation of hydrogen rail systems, or Hydrail, as part of Metrolinx's GO rail line expansion and modernization efforts. The technology is demonstrated and commercialized in Europe, and one of its leading innovators, Alstom, is now a major player in Canada with its acquisition of Bombardier Transportation. Panelists will discuss the introduction of the Hydrail concept to connect to the Canadian's passenger mobility system and the need for a Canada-wide network of green hydrogen fueling systems that can support both via via rail and regional networks of rail mobility in their drive to low-cost, zero-emission electrified rail technologies. And I can just mention that I personally have advocated for the concept of Hydrail for many years now, fundamentally because when you compare the costs of putting onboard systems onto rail cars, as opposed to putting up catenaries and protective systems and raising bridges and doing many infrastructure projects that are longer and harder to implement, to me, it's no contest. But then the question is, have we arrived yet? Is this truly a commercial opportunity? So on that note, I'd like to introduce our first speaker, Mr. Rob Harvey, who's the Director of Infrastructure Programs at Cummins. And Rob, if I could ask you to just introduce us to yourself with a few words.
Certainly, thanks, Robert. I'm Director of Energy Infrastructure at Cummins, New Power Business Unit. And I've worked in this space for going on 9 years, both for electrolysis and for heavy-duty applications such as Hydrail. It's my pleasure to join you today. What you're looking at in this picture is a fuel cell composition on top of the Caradia Island, the world's first zero-emission fuel cell electric train. Cummins designs and builds the fuel cell compositions, which include the fuel cell, the hydrogen management, water systems, electrical systems, cooling, you can see the radiators there, and the master control system. And this is one of the most demanding applications there is in terms of the rail application, the duty cycle, the railway codes and standards for EMC, shock and vibe, and others, and the reliability requirements. Just want to give a brief introduction to Cummins. Cummins has been around for a century. We're best known for diesel engines, but our New Power business unit has battery electric and fuel cell product platforms, and I'll just highlight a couple of them. And of note, and some of you recognize me from Hydrogenics, Cummins acquired Hydrogenics in September 2019, and we've been integrating and growing since then with as part of the Cummins family. Just highlight a couple here. One is battery electric vehicles. The first one there is the Bluebird school bus. The second one, Class 8 trucks, and that's the fuel cell electric traction motor, the full integration, and that's one of the projects of the California Energy Commission. Number 3, we've done fueling stations around the world, most recently in Quebec and here in Mississauga. 4, of course, we'll be talking more about the fuel cell electric trains in this presentation. And 10 is the Markham Energy Storage Facility, a 2.5 megawatt, 1,000 kilogram a day electrolyzer plant that we did a joint venture with, operating with Enbridge. The choice in Canada for zero-emission rail really comes down to 2 things. We're replacing diesel systems. We can go overhead catenary route or the fuel cell electric. And as Robert's already mentioned, one of the biggest advantages is the upfront capex for the overhead catenary system is much higher than it is for the fueling infrastructure for Hydrail systems. Avoids the roadwork and network disruptions, and utility relocates for faster implementation and revenue capture. It doesn't take years and years to get a fuel cell electric commuter system in place as it does with an overhead catenary system. Greater operational flexibility, as we've seen in Europe, because it can operate on the same lines as diesel and under the electrified lines. It's a scalable solution that will grow with ridership, add over time, and the rolling stock costs and the fueling infrastructure costs will decrease dramatically as we have volume production over the next decade. Just give you a couple highlights of the distinguishing features and value proposition for our fuel cell power systems. One of them is that it does not require a humidifier. They're self-humidified units. We take the water that's produced during the operation of a fuel cell to humidify the membranes. All fuel cell needs humidified membranes. Ours does it automatically. We don't use high pressure components, have compressors. We have a low pressure design and just use industrial blowers. And that improves the reliability, but also the size of the total system as well. You see on the bottom left there, that's a 45 kilowatt fuel cell power module. We have a patented unlimited stop-start capability, which does not cause any degradation for the unit, which is obviously in this sort of duty cycle is a good thing. And also you can operate these at sub-zero temperatures and store them at sub-zero temperatures. Our fuel cells can freeze without any requirement for external heating of trains in the stabling yards. On the bottom right there, the flexible architecture, I've mentioned the fuel cell composition, and this is rated at 200 kilowatts for the Karadia Island. A number of panels, one of the panels earlier today talked about the need for hydrogen infrastructure. We certainly agree with that. We have a very strong product capability in that area as well. You're looking at here is the Hylyzer 1000. It's our product platform for high hydrogen production. The schematic there is for a 20 megawatt plant, which is 4 lines of this 5 megawatt module, and is capable of producing 8,000 kilograms of hydrogen a day. And that is a project we're actually right now commissioning our first commercial plant with Air Liquide in Bécancour, Quebec. Some of the characteristics, it's the highest power density system in the world. Each of those electrolyzer stacks is 2.5 megawatts. It's the size of a large bar fridge. It also has the highest efficiency of any plants and a very small footprint. So you've got 500 square meters for the components for 8,000 kilograms a day. Our systems also operate at 30 bar pressure, and we manufacture them on site. We don't assemble the stacks on the customer premises. It's made in a factory. The factory acceptance testing and then shipped it in skids and interconnected and assembled on site. So what's holding us back? When you look at Hydrail, we hit all the check boxes. The rolling stock's available. The Caribbean Island's been operating in public service since September of 2018. Storage, fuel production, all of these technologies already exist. But there are some challenges. We are at the early commercialization stage, and for this, and it's a newer product. The hydrogen fueling infrastructure, although the technology exists, the fueling infrastructure isn't there, and that's something that needs to be built as part of these deployments. Volume production for CapEx reduction, this is a huge one. At this stage, we know, and many independent groups have looked at the learning cost curve for Hydrail. It's impressive, significant cost reductions over time, but we need the volumes to get there. Finally, the technology financing risk. It's a newer technology, versus a century-old overhead catenary system. There is less financing risk for an OCS system. I might say that there's a higher political risk by the disruptions it might cause, but on technology financing, that's a barrier that we need to overcome. And finally, the long-term COVID ridership impact. We're dealing with transit operators that are facing unparalleled challenges and dealing not only with COVID today, but in the possible reduction in ridership in the future, even as we come back to a new normal. That's what's holding us back. But the story of Hydrail is compelling, and I think this story has got legs, and we're going to see it happen in Canada. Thank you.
Thank you very much, Rob. We'll come back to you with some questions later, but I think right now we'll turn the microphone over to Mr. Chris Norris, who's the Director of Business Development and New Energy Systems at Siemens. Tell us a little bit about your background and what you're doing these days, Chris.
Sure, happy to. My background is that I've been part of Siemens for 5+ years now, and you may have heard that recently Siemens Energy was carved out of Siemens Industrial and is now a separate company traded on the Frankfurt Stock Exchange. So I'm glad to be part of the Siemens Energy company now as we move forward into the future with a focus on hydrogen through the new energy business. There are 4 divisions within Siemens Energy: generation, industrial applications, transmission, and those are essentially the 3 that are established. And then the new energy business is this product of all the research and development that we've been doing on hydrogen production over the past 10 years, rolled into a separate business unit. And so I want to start by talking about Siemens' strategy as it relates to hydrogen production. Certainly we talk about hydrogen production across a bunch of different sectors. The term of art now being used in the hydrogen sector is sector coupling, where we take renewable energy, convert it to hydrogen, and then focus on reducing greenhouse gas emissions in these difficult to abate sectors that are shown here in purple. Today's focus, of course, is on mobility in the bottom left there, and we can see that, of course, we can do direct electrification or we can power using fuel cells. And of course, that's what today's session and in fact the entire conference is about. But Siemens is, of course, focused on large-scale deployments of green hydrogen production facilities in order to do what's called complementarity, in the sense of producing hydrogen that's affordable and not tied specifically to necessarily an end use case. And one thing I'd like to point out is something actually, Bob, you mentioned to me a few months ago, which is that hydrogen is electrification. We talk about this term sector coupling and what does it mean and how do we unpack that term. I think that the key takeaway here is that hydrogen, green hydrogen, is electrification as we electrify these difficult to abate sectors. Siemens product itself, I think our marketing department must have gone to the same naming school. as Cummins and Hydrogenics, because our product known as the Sealizer is a combination of Siemens and electrolyzer, and the 300 represents the third generation of electrolyzers in our portfolio. This is a 17.5 megawatt unit comprised of 24 individual modules about the size of a residential fridge, maybe a little taller and narrower, that operates at atmospheric pressure and electrolyzes pure water into its constituent parts, hydrogen and oxygen, captures the hydrogen and compresses it downstream, and produces 330 kilograms an hour, or about 8 tons a day. Of course, it's one component of a much bigger system that would involve capturing power from the grid or from a renewable electricity system, rectifying that, because of course electrolyzer is a DC system, and compressing it and purifying it and dispensing it downstream. You may have seen today that there was a press release that Siemens Mobility, which is part of Siemens Industrial, is working with Deutsche Bahn in Germany to test this new Mireo Plus H hydrogen version of Siemens' well-established electric train. And you may have also heard that a few weeks ago, Siemens Mobility and Siemens Energy signed an MOU. This is relevant and interesting in the fact that, of course, they used to be part of the same company, and now as separate companies, they are engaging in joint projects. And one thing of note is that previously, prior to the MOU, we were essentially working with Ballard on this project, and we're selling trains into the marketplace without the added benefit of a refueling system. So, of course, with Siemens Energy's capabilities around electrolysis and Siemens Mobility's capabilities in conjunction with Ballard around mobility, we are presenting a whole package solution to the market. And with that, I'll turn it back over to you, Bob. Thanks very much.
Thank you very much, Chris, and I'll have some questions for you as well. So our final speaker today is Noah Hewlett, who's the Vice President of Rolling Stock Sales and New Business Development for Alstom. Could you tell us a little bit about yourself, Noah, and then just tell us what you're up to?
Sure. Happy to do it. I'll try to be brief so we can get to the content here within our overall presentation. So I'm Noah Hewlett. I lead business development and sales for rolling stock at Alstom in North America. Just highlighting as Alstom is a true global leader in the transportation sector within our existing digital age, with a real focus on trying to address the challenges of tomorrow in a responsible and overall ecological sense. So just a quick highlight on Alstom's financial performance last year. We are a fairly large global company, and if the acquisition of Bombardier Transportation does go through as intended, we should be a significantly larger organization able to spread and continue to develop and produce products for our global customers. Alstom is truly leading the way through a greener and smarter mobility worldwide with our comprehensive solutions portfolio, highlighted today with our Island product, our hydrogen-powered multiple unit train that is in service, currently in revenue service in Europe. We're looking to expand that footprint beyond Europe into North America in particular, as well as other areas throughout the world. Talk briefly on the Caradia Island product. As Rob introduced earlier, Hydrogenics was our original partner. Now Cummins is our wonderful partner providing hydrogen fuel cell technology for our Caradia Island. We have been operating in passenger service in Germany since 2018 with over 180,000 kilometers over the last 18 months. We're continuing to expand that footprint in the German and French regions, as well as signing MOUs in Italy, and expanded service demonstrations throughout Europe, including the Nordic regions as well. So we are really happy and pleased with this solution to be, again, leading the way with this particular product, and think it'd be a wonderful item to introduce into North America, and are continually working with our partners here with CUTRIC and throughout the rest of the industry on how do we get this product into North America and ensure that we're spreading this green technology throughout the world. And at that point, I'll wrap up because I know we have lots of questions and panel to address.
Well, that's great. Thanks, Noah. And yeah, well, we could roll right into some questions right now. So I'd like to direct my first question to the whole panel, and perhaps we can take responses back in the same order, speaking orders we had. And this is the question. In CUTRIC's national scan of rail innovation technologies, performed from 2018 to 2020, we found that Hydrail, or hydrogen-propelled rail innovation, was top of mind for several stakeholders in the industry, especially for passenger mobility, but is yet to happen in Canada. What is stopping hydrogen propulsion for rail mobility from finally taking root in this country? And first from Rob.
Thanks, Bob. I think I touched on that briefly in my remarks, but I think there are a couple of things that I mentioned. Just being new. If you'd asked the same question in Europe, Europe is a lot farther ahead for us. We've seen penetration, as Noah mentioned, in Austria now, in France, in other markets. But one of the things that is crucial is overcoming the project financing, the technology risk, and getting the financing for it for starters. But one other one I will mention, just to elaborate on, is in Canada right now and around the world, is the COVID ridership impact. I spoke at the Canadian Urban Transit Association conference last week. I heard a number of speakers, transit operators, and I know we know they have it tough, but the ridership has just plummeted. And it's really, they're asking themselves, it's not when the ridership's going to be coming back to the pre-pandemic levels, but if it will be coming back as we adopt in a new normal. And so that's, if you overlay any introduction of new technology with this COVID situation where the revenues are down, it makes it doubly difficult. We've got government stepping in, but it also is sort of a silver lining that I see for fuel cell versus overhead catenary. If ever you needed a solution to scale in with unknown future versus an overhead catenary where you build everything up front for whatever you're expecting, that's a real advantage of Hydrail.
I know, but you're right. There may actually be a silver lining there in terms of making it more economic to do it piecemeal. So, Chris, what about you?
Well, I agree with Rob. I think he's hit the key points. And one of the key points as it relates to pricing, just to sort of pull back the layers a little bit, is operations and maintenance. I mean, it's one thing to know how much a train is going to cost or what the development life cycle will be, but oftentimes, we're entering into 30-year operations and maintenance contracts, and those are very difficult to price with a new technology. So it's a question of both on the operator side and on the producer side. How do you get to a level of certainty around O&M that is going to allow you to operate in a favorable fiscal situation over the lifetime of the operation of the train?
Okay, thank you. And Noah?
I think good points highlighted by both my colleagues here on the panel. One of the things, when we talk about North America in particular, we look at the particular modal transport solutions. Predominantly in Europe, we look at our island product. It's much more of the smaller regional transit, rapid regional transit systems that are based off of this single deck concept. North America was built on the freight railroads' backs on our rail technology, so we are still utilizing technology that matches that from our commuter railroads in particular, with locomotive-hauled coach solutions where we've got a large locomotive pulling multiple double-deck coaches or single-deck coaches. We look at most of the rail agencies around. That is a difficult technology to replicate when these ridership models are based solely upon this concept and are looking to displace we're looking at roughly PPHD levels or passenger transportation levels that are significantly higher and more dense than what we're capable of directly replacing with comparable technology. So I think kind of getting the equivalent technologies and matching that ridership or changing and displacing that ridership loss. If we took the large commuter trains off and replaced them with smaller, say, island, for example, passenger capacity on an island is much less than that of a 10-coach locomotive hauled consist. So I think there's a bit of that where we're looking to solve for that displacement right now, because on the fuel cell technology is not quite there that we can replace the power output for a locomotive hauled coach consist.
That's a perfect segue to the next question, actually. So hydrogen propulsion for cross-country freight is more arduous. It would require a Canada-US alignment on hydrogen fueling and a cross-provincial alignment on fueling. Is it possible to envision that one day passenger rail systems like Via Rail, Amtrak, and regional systems like GO and EXO would benefit from a communal hydrogen fueling supply chain with freight? What needs to happen for that to arise in the next 5 years? First with Rob.
Wow. I think the low-hanging fruit, I think we'd all agree, that is, the LRT, the commuter Hydrail that we've seen with trains such as the Crowley Island and the trains that Siemens is developing as well. The locomotive or the freight is a tougher nut to crack, and one of the reasons is just the power density, the output required for the fuel cell systems, and the fact is that they're not fleets. The great thing about fleets with fueling infrastructure, they all come home at night. It's just like a bus fleet or a delivery van fleet. The trains come home, they're stabled, they go through the process, and the fueling infrastructure is sized for the size of the fleet. As soon as you go cross country, you need to build the fueling infrastructure out over large areas, and in North America, it really doesn't get any bigger than the North American rail network is all of North America. To your question, though, Bob, it certainly would help. I don't think we can necessarily do it in 5 years, but the fueling infrastructure for for freight rail would be the same as it would be for a cross-country passenger rail as well for longer distances. The infrastructure, I think, would serve both.
What about you, Chris?
Yeah, excellent points brought up by Rob. I certainly don't dispute any of those. I think he's identified the key challenges. Again, I think what I would like to do is kind of peel back the layers a little bit and look at, we're talking about Hydrail, we're talking about hydrogen in rail, but we've, I think Noah mentioned it at the end of his comments, and Rob has certainly made it clear in his comments that, the energy density required for rail, transit is huge. We also have trillions of dollars of existing rolling stock capacity out there. And if we step back a moment and look at what is our goal in electric or hydrogenizing rail, so to speak, if the kind of phrase like, how else can we decarbonize the rail infrastructure? And there are other ways that we can do with existing infrastructure, and one is through synthetic fuels. It's it's a technology that's established. It's a possibility of having a net neutral carbon footprint. It has its own share of limitations, but at least there's a possibility there from how do you decarbonize, if not electrify, these heavy haul transit options. So synthetic fuels is something that I think needs to be part of the overall energy transition, especially when we're talking about what to do in the near term.
Okay, thank you. And how about you, Noah?
No, I think both my colleagues again make very good points. If we're going to truly be successful with this type of ambitious change, I mean, we're talking about a step change in the way that I'm speaking from a regional perspective. The way that our region was built from a railroading is we're built on diesel freight. So going from this type of step change to an alternate fuel source is a significant investment and requires a cultural shift as well, not just having the infrastructure in place. So I think my colleagues addressed the infrastructure side of things, but for us, it's a continued cultural investment between our countries in particular, if we're going to have any type of cross-border or even cross-provincial relationships, of this clear, consistent message that this is the way of the future. This is how we need to invest to really address. And once we address the cultural aspect of it, then we find that there's more of a will, right? And as there's more of a will, the way tends to become a little bit clearer. Funding becomes a little bit more obvious, and these solutions tend to present themselves in much clearer ways.
Okay, thank you. So now I'm going to have a question from our audience, and there's some interesting questions coming up there. In fact, there's one here that I would have asked myself, and that is, presumably, this could move faster if we had a government, either at a provincial or the federal level, who wanted to move ahead with a strategic procurement. And so the question is, if we had a government agency that quickly wanted to move ahead and placed an order, how quickly could the first Hydrail be deployed? If it was for, let's say, for Commuter. Any one of you?
I probably the best suited to answer that question is we have one available for purchase today.
Fair enough.
Again, so there's one item that does need to be addressed, that is a little bit of the elephant in the room when it comes to introducing our rail technology that we have in operation in Europe. There are some regulatory hurdles that must be cleared. So there is some engineering work to meet with the appropriate regulatory requirements for train operation in North America, in particular around crash compliance, electrical wiring, smoke and flame and toxicity associated with the NFPA fire codes. So those are clear regulatory hurdles that need to be met. On average, we say we try to introduce new trains from the initiation of procurement to prototype in 36 to 42 months, with going into a regular production or a serial production mode, roughly 44 to 48 months in total from the initiation of procurement. And again, there's some regulatory hurdles to clear, so that timeline could stretch a bit depending upon the cooperation. We have good discussions within the United States and Canada as well, Transport Canada and the FRA in the US, on how we could adapt and utilize our existing hydrogen systems in those respective countries. We think the regulatory process would go fairly quickly, but again, there's always some potential unexpected hurdles that could occur. So in overall, I'd say, if we were issued a procurement today, we'd probably be looking at roughly 4 years before we'd start seeing those trains out and running around in actual revenue service.
Well, 4 years sure beats an infrastructure project that could take 10.
Sure.
So I think that answers the question, but it didn't occur to me, frankly, that some of the regulatory and permitting issues might actually just add to the time.
There is certainly some delay that can occur from meaning the EN. There's not a full equivalency between the EN standards and what we traditionally accept here in North America. So there are some items that need to be addressed from an engineering level that could make the vehicles fully compliant with our regulatory standards here in North America.
Okay, well, thank you. Mm-hmm. So I'm going to direct this next question to both Rob and Chris, and hopefully you have an answer for me, which is, when we look at automobiles and trucks, and we know that there's a whole host of new fuel efficiency standards and clean fuel standards, basically mandates that will be coming down the pipe. Is there anything like that? Is there an equivalent? I have to confess up my ignorance. Is there anything like a clean fuel standard that would apply to rail that would help accelerate the uptake of cleaner, greener solutions?
I don't know if you want to start, Chris.
Well, I think the clean fuel standard is intended to be the standard. But and I'm not an expert in this particular regulation. So I think the question is going to be, how can the clean fuel standard be used to apply to these types of applications?
Indeed.
Yeah, the thrust behind the clean fuel standard is to sort of set a quantity rather than a price on the amount of clean fuel that is going to be utilized. And so whether you're using cars or trucks or any other fuel consuming device, the clean fuel standard is intended to to specify the amount and then have that amount increase over time with a corresponding market for the credits that are produced as a result. So I don't know if there is a separate or equivalent clean fuel standard that would apply in this case, or if the approach would be essentially the holistic view towards making one clean fuel standard for all modes.
Thank you. Rob, any thoughts?
Yeah, the only thing I'd add, Bob, Robert, is that in the U.S. For I believe it's Class 1 locomotives, there are different standards that have been introduced for the diesel locomotives in terms of reducing the emissions, and that new locomotives need to meet those standards. With some of the older locomotives, they're grandfathered with the standards when they were introduced.
Okay.
But that really is focused on making diesel progressively cleaner. I think one of the differences here is the size of the fleet and the cost of doing it. You were talking about, the public procurement. I think a low carbon fuel standard would certainly help with the operating costs over time. But ultimately, it's the will of the transit authority and the government to move forward with zero emission alternatives, and Hydrail is probably a bigger impetus to get this moving.
Okay, thank you. So I'm going to take one more question from the audience again, and this one gets a bit technical, and I don't know if there's an easy answer to this, but it's one that keeps coming up. So let's conceptualize that we do have a hydrogen-fueled train, whether it's commuter or freight, but let's say it's commuter and it's a long run. Let's say something like a VIA. Would it make more sense to have fueling stations along the line, or would it make more sense to have a tender that the trains would be pulling? Now, I know that there are both concepts out there, and so I presume that it would depend on the application, but any of your thoughts? Who first?
I can go first. My understanding, and it's incomplete, but for passenger rail, I do not believe that tenders would be allowed. So I think for freight applications, having a tender would be possible, but not for passengers. But okay. The good news is, and I'm more familiar with the island than I am with Siemens trains, but these commuter trains can do 800 kilometers. So a Toronto to Montreal is not difficult, and that could be done without refueling.
Okay, good to know. Okay, so the tender would only apply in a freight situation, fundamentally. Okay.
Correct.
I'm going to take one more question from my cheat sheet here, if I might mention. This one was kind of answered by Rob, but I think I'm going to ask it again because it's kind of important. COVID-19 has destroyed ridership and regional budgets. What is the impact of COVID-19 on the rail sector overall, and how will the impact rail electrification planning and investments going forward? How can we bring riders back to rail? And Rob kind of answered this, so I'm going to give it to Noah first, and then to Chris.
Sure. Thanks, Rob. I appreciate that. It's a big concern, right? I think we're all looking at the way our customers are trying to manage this from the crisis that New York City is in right now, with a lack of dedicated funding to support their service to other customers throughout the United States. Although we've seen some positive areas around COVID, if we look as closely as just the recent election in the United States, there have been significant ballot funding measures that have passed by overwhelming majorities. I look to Austin, Texas, as the most recent example of this. I think there is a considerable will towards a movement of a full greener mode of transportation throughout our region in North America, and I think that's very consistent. I think generationally that's very consistent as well. We see this next generation of high schoolers, millennials, Gen Z, whatever you want to call them, are significantly invested in these cleaner modes of transportation. I think, again, this is an opportunity for us to rethink how we are moving our industry forward. And we have the opportunity to reset here. We have the opportunity to let some of the aging infrastructure and technology age out appropriately and move forward with better, cleaner technology that can sustain our environment in the long run.
Okay. Chris.
We are less than 1 year into this pandemic. Noah mentioned that in best case scenario, a commuter train in North America with their technology would be 4 years out. And we know that from a time to market, actually Alstom is ahead with respect to this particular application. So what does it mean then to know that there's going to be at least 4 more years before a train is on the tracks in North America? All that to say, it's conjecture at this point to say what is going to happen as a result, in a change to the future as a result of the pandemic. News coming out every day about potential ways to address this pandemic. And so I think, of course, the pandemic is much more than a minor setback or a blip in the historical trajectory that we're looking at in this technology. But at the same time, we are looking long term with this. And I think all the points that Noah brought up about the demographic change in approach to transit are very valid, and they do apply in this case. So it may be too soon to say, but I have a feeling that we will still need trains and significant amounts of green infrastructure in the future.
Excellent. So this is a corollary maybe to the last question. I'm aware that before COVID, Go Transit, Metrolinx were ready for a major expansion in regional commuter rail. And it was a significant expansion, and it would have been something where Hydrail clearly would have had an opportunity to be at least one of the potential solutions, certainly supplied by some of the bidders. But because all of you are in the business, you probably know more about this than I do. But are you aware if that's proceeding? Is it on hold? Or is it going more piecemeal? Who wants to try?
Robert, I don't really know how it's going, but I think if you look at I agree with the comments of the other panelists. How do we go forward? The COVID challenge is real. Municipal governments are strapped. All governments are strapped. For a large infrastructure project, I think one is the commitment for a zero-emission solution. And the Hydrail has the advantages. There is a natural replacement of existing rolling stock that's required. And do you scale into this? The Hydrail gives you a zero-emission solution. You can scale into. You can have the government's commitment as ridership increases, as government programs can help support these, as opposed to saying, okay, we need to make one great big expenditure to put in overhead catenary systems to make this work. COVID has made that second option just a lot tougher now.
Indeed. Anyone else want to address that?
No, just a quick comment. I think that there's ongoing procurements as of right now, and I think strategy is still being developed and refined. So I can't really comment quite a bit on that as of right now. But again, I think it's worthwhile to, again, we're looking at our technology, we're looking at it as a direct replacement. As Rob has made mention before, a lack of catenary infrastructure investment is a key driver here. This is a direct replacement technology. We literally introduce the trains and they go. It's about as complicated as that from an infrastructure compatibility perspective.
Okay. So I think we're coming close to the end of our session. So what I'm going to do, I'm going to ask one final question. And this again came from our audience, but it's one I might have asked. You're probably all aware that both the federal government and the Ontario provincial government are working on a strategy around hydrogen deployment, which is really encouraging and probably a long time coming, in my opinion, but I won't say any more on that, other than I'm aware of what's happening at the provincial level to some extent, a little bit more aware of what's happening at the federal level. But bottom line, I'm not exactly sure what they're going to do specifically about the technology we're talking about. So the question I'm going to ask you is, what would you collectively and individually like to see in that strategy that would help this technology move forward? And again, I'll do it in speaker order. Rob first.
I think, Robert, you're referring to the Minister Urick's announcement last week for the discussion paper and input for the hydrogen strategy.
Yep.
I think whether we're talking about trains or buses or trucks and the fueling infrastructure, one of the keys is lowering the cost and building out, and that comes through volume production. So incentives that help accelerate the adoption of fuel cell electric fleets, and it is fleets, whether they're commuter rail, whether they're transit buses, whether they're class 6 delivery trucks, will all help that development. And it's a virtuous cycle. If you have initial fleets, you need initial fueling infrastructure for hydrogen production and fueling. And as that ecosystem grows, we're better able to, and the costs come down, we're better able to grow as an industry.
Okay, and Chris.
Yeah, again, I would agree with Rob. And, I think the two key parts that we look at when we're looking at large-scale deployment of green hydrogen generation is electricity prices and offtake agreements.
Yes.
And that's where governments can play a role. It's difficult to change things on the input side. Electricity is a hot-button topic, of course. But contributing on the offtake side is a way to do, as Rob says, increase the volume, and do what I think the Hydrogen Council calls complementarity, right? It's like we don't necessarily need to build an electrolyzer for a train network and then a separate one for a power plant and a separate one for a separate application. Hydrogen is hydrogen. It's going to be moved around. And what we need to do is be building up the supply side in parallel with the demand side, and in such a way that the high volume, high demand applications can create that market growth and the volume that will be used for the sort of less intense demand sectors, right? Maybe the fueling of some local bus fleets and things like that. So I think the complementarity and the merging of the demand side to make economic sense out of the supply side economies of scale is what I'd like to see happen, and what I'd like to see the strategy address.
Okay, thank you. And finally, Noah, last word.
Sure, thank you. I appreciate it. And thanks again to my colleagues here. Very, very good points. I think Rob raised a very good point as well on the incentive. Right? When we look at this from what is the incentive from our, as a car builder and a producer of the equipment, what's the incentive for our customers to transition away from existing technology? Hydrogen fuel pricing, and as Chris mentioned, on the electricity side, that pricing, the regulatory side of the pricing is key. Similarly, on the equipment side, what is the incentive for Metrolinx to transition from a diesel fleet to an alternative fuel or to a greener fuel source? There should be some incentive on that side to make them want to transition. That will help spur growth within the industry, is this simple incentivization. I think that's key. And one other point that I think is worthwhile from my previous comments, when talking about standards from equipment, I think a consistent standard for equipment across the area, across the regions would be key. So there's one set of guidelines that all competitors can work off of and work towards. This bit of homologation will allow for more competitors in a market segment that could use more competitors. Right? I mean, Alstom is very pleased to be the first and only operator of a hydrogen-powered train today, but the competition spurs growth and innovation. That's how we continue to grow this market segment into a new standard for transportation.
Okay, well, that's great. This has been a great discussion, and thank you. And I think if I can summarize what it sounds like from this last round, was that we're looking at big users and big producers to find an economic path forward, probably with some government assistance, and then the smaller users can come along and take benefits from the economies of scale that came out of those large generators and large users. And a lot of that will leverage our electricity grid, which is, as you know, is almost totally green these days, and certainly low emission and zero emission at night. So I think the connection there is becoming clear. I thank you very much, gentlemen. And I think on that note, we can go on to the next panel and hope to see you all soon on the next conference, or sooner.